Hi students, welcome to today's class. So today also I am going to explain very important concepts which are useful for your JEE mains examination, but also board examinations, for all competitive examinations. Okay now. So such type of one problem is this. See the problem. Find the remainder when x is equal to 5 to the power of 5 to the power of 2 the power of 2 the power of 2 the power of. How many 5s are there? 24 5s are there. 24 times 5 is divided by 24. If this number, that is 5 to the power of 5 to the power of 5 to the power of 5, like that, 24 5s are there, is divided by 24, then what is the remainder? We have to find out. First see the problem. 5 to the power of 5 to the power of 5. Solution. X is equal to 5 to the power of 5 to the power of 5, so on 24 times. That is 24 5s are there. We know one thing. 5 to the power of anything. 5 to the power of 5 to the power of 5. So definitely it is an odd number. Understand? So it is an odd number. So therefore x is equal to 5 to the power of, this is an odd number. 5 to the power of 5 is an odd number. So 5 to the power of 5 odd number to the power of 5, again odd number to the power of again 5, odd number. On the whole, here the base is 5, whole to the power of some odd number you will get, whatever may be that. So that is equal to x to the power of odd number, general form we can write down 2n plus 1, where n is a natural number. This can be written as 5 to the power of 2n into 5. Okay now, we can write down easily. Now this is equal to 5 square whole to the power of n into 5. Can I write it at? Yes, I can write. 5 square is equal to 25 whole to the power of n into 5. Okay now, 25 whole to the power of n into 5. Already I told, divided by 24 means you have to express this 25 as something 1 plus 24 or something plus 24, something plus 24. That is easy. Clearly 25 can be expressed as 1 plus 24 whole to the power of n into 5. 25 can be expressed as 1 plus 24 whole to the power of n. Now by the binomial expansion, we know that, so nc 0, so this is a 1 plus nc 1 into 24 plus nc 2 into 24 square. Last one ncn into 24 whole to the power of n plus into 5. See here, nc0 value is 1, that is equal to 5 plus this 5 into whole thing. Again if you see here 24 square, 24 whole to the power of n, you can take 24 common outside. That means 24 into some integer. 24 into some integer. On the whole, our problem x is equal to 24 into some integer plus 5. So the number x can be expressed as a 24 into, that means dividend is equal to divisor into quotient plus remainder. Therefore, the remainder is equal to 5. Understand? So very easy. The first thing, x to the power of 5 to the power of 5 to the power of 5 24 times. Clearly x to the power of 5 is an odd number. That means 5 into 5 into 5 into if you multiply. So it is an odd number you will get. Like that, 5 to the power of 5 is odd number to the power of 5 is a odd number. Understand this? So 5 to the power of odd number you will get. Odd number is 2n plus 1. So this is a 5 to the power of 2n into 5. This is a 5 square 25. 25 I wrote down 1 plus 24. Binomial expansion I did. So nc0 means 1, that is equal to 1 into 5, 5. Of course, this is a 24. We can here 5 into 5 into 5 we can multiply, whatever may be that. but you can take 24 common outside. Afterwards, some integer. Therefore, the given number x you can express as a 24 into some integer plus 5. Understand? Plus 5. Therefore, dividend is equal to divisor into quotient plus remainder. The remainder is 5. Okay now? I hope that you understand this solution. So, let us go for next concept. Hi students, welcome to this concept. So, now we are going to see the expansion of x plus y whole to the power of n plus or minus x minus y whole to the power of n. These two expansions, that is x plus y whole power n plus x minus y whole power n and x plus y whole power n minus x minus y whole power n, these two expansions you should know, so that basing on that there are some very important problems are there. Now, first let us see the expansion of x plus y whole to the power of n. So, the expansion of x plus y whole to the power of n is nc0 x to the power of n plus nc1 x to the power of n minus 1 into y, nc2 into x power n minus 2 into y square plus so on, last one ncn into y to the power of n. Understand this. Now, let us see the expansion of x minus y whole power n, x minus y whole power n. You know that this is alternate, plus and minus will come. So, nc0 x power n minus nc1 into x power n minus 1 into y plus nc2 into x power minus 2 into y square plus the last term is minus 1 whole power n into ncn y to the power of n. The last number, either that is a plus or minus sign, depends upon the power n. Okay, now that's why I wrote minus 1 whole power n. Okay, now these are the two expansions. Now what I am going to do is, I will add these two equations. That is, this is a first equation, this is a second equation. First you do first equation plus second equation. Let us see what happens. So, if you do the plus, you will see here x plus y whole power n plus x minus y whole power n. If you see here, plus nc1 minus nc1 plus here plus nc3, here minus nc3, here nc3, here nc3. That means odd suffixes 1, 3, 5, those numbers will be get cancelled. So, what remains? nc0, nc0, 2 times nc0, nc2, nc2, 2 times nc2, those terms will come. That is 2 times nc0 x to the power of n plus nc2 x to the power of n minus 2 into y square plus nc4 x to the power of n minus 4 into y to the power of 4 plus so on, so on. So, last number we cannot say, that depends upon the n value. Understand? So, on the whole, what you have to observe is 2 times nc0, nc2, nc4, 0, 2, 4, 6, 8 suffixes, even numbers will come. Now, let us see the subtraction, that is 1 minus 2. Let us see that 1 minus 2. So, here x plus y whole power n minus x minus y whole power n. So, if you subtract here, here you will get a minus plus like that will get. Here nc0, nc0 will get cancelled. What remains? nc1, nc1, nc3, nc3. That is 2 times nc1 x power n minus 1 into y plus nc3 x power n minus 3 into y cube plus nc5 x to the power of n minus 5 into y to the power of 5 plus so on. nc5 x to the power of n minus 5 into y to the power of 5, so on. On the whole, what you have to remember is, if it is a plus, 0, 2, 4, 6, 8, even numbers will come. If it is a minus, 1, 3, 5, so on, odd numbers will come. Okay, now? So, this is the concept. So, basing on this concept, there is one important problem is there. So, let us see that problem. Okay, welcome back. So, let us see this problem. So, prove that root 10 times root 10 plus 1 whole to the power of 100 minus root 10 minus 1 whole to the power of 100 is an even integer. We have to prove that this expansion is an even integer. Okay, let us see that. Coming to the solution here. So, this is a root 10. So, see here this expansion. So x plus y whole to the power of n minus x minus y whole to the power of n. So what are the, here minus is there. So immediately what we have to remember? We have to remember that the suffixes will be odd number. That is 2 times. Again one more thing you have to remember, 2 times. 2 times 100 100c1 root 10 whole to the power of 100 minus 1 99. Of course here 1 to the power of 1 no need to write down, plus 100c3 root 10 whole to the power of 100 minus 3 97. One more I will write down, 100c5 root 10 whole to the power of 100 minus 5 95, plus so on. So this is the expansion. So what you have to remember, if it is a minus, so here the suffixes will be 1 3 5 7 odd numbers. Of course starting will be 2 will be there. Understand? Now let us see here then. So take a 2 outside, let us multiply the root 100 to each and every number, that is equal to 100. Otherwise you will do one thing. So okay, we will do the value. So 2 root 100 root 2 root 10, that is equal to 100 c1 into so this is equal to, sorry, okay, you multiply inside root 10 into root 50, sorry, root 10 into root 10 is equal to how much? So root 10 into root 10 whole to the power of 99. So this is equal to root 10 whole to the power of 98. Okay now, plus 100c3 into root 10 whole to the power of, this one will come now here, 98. So this is a 100. So this is a 100. This is a 98. This is a 100c5 root 10 whole to the power of 96 plus so on. Understand this? Right, very nice. Next one, 2 times 100c1 into, so this is here. So you should not conclude that sir we got 2 into something, no sir. So therefore 2 into something even number. No, we cannot, we should not decide like that. 2 into an integer, then only 2n is a even number. We don't know whether it is an integer or rational number or irrational number. Why? Because here root 10 is there, that we have to decide now. So this is equal to 10 to the power of 100. So root 10 means what? 10 to the power of 1 by 2, that is 50 by 2. 100 by 2, 50. So 100c3 10 to the power of, this is equal to 49, plus 100c5 10 to the power of, this is equal to 48 plus so on. Understand this? So this is 10 to the power of 50, 10 to the power of 49, 10 to the power of 48. So what you observe? This whole thing, whether you will get an integer or not, surely definitely an integer. That means a 2 into an integer. So 2 into an integer. So 2 into integer means what? Is it not even number? Understand? So here in this stage, at this stage you should not decide. At this stage you should not decide it is a even number. Why? Because you have to verify that this is an integer or irrational number. So now it is a clearly an integer. Why? Because 10 to the power of 50, 10 to the power of 49, 10 to the power of 48. Understand? At this stage you cannot decide. Why? Because root 10 whole to the power of 99 is an irrational number. After multiplying with root 10, then will become a integer. Okay now, right. I hope that is a very nice problem based upon the previous formula. Okay. So I hope that you understand this. Now so let us go move to next concept. My dear students, I am going to explain now a very important concept, something deep into the subject, that is use of complex numbers in binomial theorem. Use of complex numbers in binomial theorem. You know what is a complex number? So a number of the form a plus bii, where a, b are real numbers, I is defined as root of -1. Now how to apply this binomial theorem on complex numbers? So let us take a complex number of the form cos theta plus I sin theta, where theta is any real number and I is defined as root of minus 1. Let us say whole to the power of n, cos theta plus I sin theta whole to the power of n. Let us see the observation. Cos theta plus I sin theta whole square, cos theta plus I sin theta whole cube. How to do this? So, binomial theorem, x plus y whole power n. So, what you will get here? So, this is a nc0 cos theta whole to the power of n plus nc1 cos theta whole power n minus 1 into sin theta plus nc2 into cos to the power of n minus 2 theta into sin square theta plus so on. Last one ncn sin, here cos theta plus I sin theta you will get. Here I sin theta whole square. I sin theta whole square. The last one is I sin theta whole to the power of n. So, here x is cos theta, y is I sin theta. So, wherever y is there, I sin theta whole to the power of theta. Now, let us once again something more you write down this expansion nc0 cos power n theta plus this is a nc1 cos power n minus 1 into sin theta I. You will get I, okay, I only. Here I square is equal to how much? Minus 1. Therefore, you will get nc2 into cos power n minus 2 into sin square theta. So, I square will become minus. Next, what you will get? I cube. I cube means how much? I square into I minus I we will get. Minus I. So, that is why next number is nc3 cos power n minus 3 theta into here I sin theta whole cube you will get. I cube. I cube means how much? I square into I. So, minus I you will get. So, minus sin theta I you will get. So on last one ncn I to the power of n into sin power n theta. So, the last thing we cannot decide why, because that depends upon n. So, we know that according to the Binomial's theorem, so this is nothing but cos n theta plus I sin n theta. So, now in this complex number cos n theta is called a real part, sin n theta is called a imaginary part. So, equating real and imaginary parts on both sides. So, let us equate real parts and imaginary parts on both sides. First to equate imaginary parts sin n theta. So, now the sin n theta formula is given as, so what are the imaginary parts? Wherever I is there, that you have to write down. So, this is equal to nc1 cos to the power of n minus 1 theta into sin theta. Next imaginary part is minus nc3 cos to the n power minus theta into sin theta. Next we will get nc5 cos to the power of n minus 5 theta into sin cube theta. So, this is equal to here cube you will get sin cube theta, sin to the power of 5 theta. So, I to the power of 5, I to the power of 4 into I. So, okay, so that is the expansion. So, minus. So, now let us equate real parts, that is cos n theta. Cos n theta means the remaining parts will come. So, cos n theta means what? This is a real part. This is a nc0 cos power n theta minus nc2 cos power n minus 2 theta into sin square theta plus nc4 cos power n minus 4 theta into sin 4 theta plus so on it will go. Okay, now. So, this is a sin n theta, cos n theta. Now, tan n theta you will get. Tan n theta is equal to how much? Sin n theta by cos n theta. Divide the first formula with the second formula, and after simplification you will get nc1 tan theta minus nc3 tan cube theta minus plus nc5 tan to the power of 5 theta divided by 1 nc1 nc3 NC1, NC3, NC5, so on, plus minus so on, divided by, you will get 1 minus NC2, remaining parts, NC2 tan square theta, plus NC4 tan to the power of 4 theta, minus NC6 tan to the power of 6 theta, plus so on. Okay. So, this you will get as a expansion. So, this use of complex numbers, I used this complex number in the binomial theorem. Binomial theorem, I used it on the complex number. So, you have to write down in the whole, what you have to remember is, for sin n theta, for sin odd suffixes 1, 3, 5. Okay, now for cos even 0, 2, 4, so on. For both the things alternate plus or minus, plus, minus, plus, minus, plus, minus, plus, minus will come. For tan theta, odd suffixes 1, 3, 5, down 2, 4, 6, up to starting 1 will be there. Understand why? Because NC0. NC0 will be there, no? So, NC0 means 1. That is 1. So, top odd, down even, 2, 4, 6, top 1, 3, 5. Here also sin n theta 1, 3, 5 odd for sin odd suffixes, for cos even suffixes. So, if you remember that, the problems will be very easy. So, based on this concept, so we have very nice problems. Let us see that problems. Welcome back. So, based on the concept that we have discussed here, we are going to see one problem. Let us see the problem. Find the sum C0 minus C2 plus C4 minus C6, so on, where CR stands for NCR. CR stands for NCR. Okay, now what is the solution here? Let us see the solution. So, after seeing this C0 0, 2, 4, 6, then you have to remember the expansion of cos theta plus I sin theta whole power n. This 0, 2, 4, 6 are the real parts, cos n theta expansion. Okay, so if you got that idea, the problem is over. So, to do this problem, so let us take the expansion of 1 plus x whole to the power of n. 1 plus x whole to the power of n. Okay, so 1 plus x whole to the power of n is what? C0 plus C1 into x plus C2 into x square plus C3 into x cube plus so on. Last one, Cn into x to the power of n. Last one, so on, Cn into x to the power of n. Now, what we are going to do is put x is equal to I, where I am telling I is defined as root of minus 1, complex number. Now, substitute here. So, this is a 1 plus I whole to the power of n is equal to C0 plus C1. So, I is C1I. So, this is equal to I square. I square means minus 1. So, this is equal to minus C2 plus C3I cube, sorry. C3 I cube. I cube means what? How much? I square into I, minus I. So, this is, you will get minus I. Minus I. So, next one plus C4 I to the power of 4. 1 you will get, minus so on you will get. See here, I will rearrange these terms whole to the power of n. So, see here, C0 minus C2 plus C4, again minus C6 plus so on will come. Here I is there, take I common outside. So, if you take I common outside, C1, C3 plus C5 so on, I. Understand? So, this is the real part. So, we want the real part. So, this is the real part. This is the real part and this is the imaginary part. Okay. Now, what we want? We want the real part of 1 plus I whole to the power of n. So, C0 minus C2 plus C4 minus 6 C6 so on. We want the real part. So, if you know the real part of, so what is the real part of 1 plus I whole to the power of n? Now, the total problem will become in the complex number. So, write it in the Euler's form. So, you know that multiply and divide with 1 by root 2 plus I by root 2 whole to the power of n. So, this is equal to root 2 whole to the power of n. This is a cos pi by 4 plus I sin pi by 4 whole to the power of n. According to the de Moivre's theorem, so this is a cos n pi by 4 plus I sin n pi by 4. Okay, na? So, what is the real part? So, real part is nothing but root 2 whole to the power of n into cos n pi by 4. So, 2 to the power of n by 2 into cos n pi by 4. So, 2 to the power of n by 2 times cos n pi by 4. So, therefore, on the whole, what is the sum of this? So, the sum is 2 power n by 2 into cos n pi by 4. Understand? So, that is the final answer for this problem. Okay. So, very nice problem this is. So, this problem will be done using both complex numbers concept and binomial theorem concept. Okay, na? So, I hope that you understand this solution. So, let us see one more problem. Welcome to this problem. So, see here, prove that NC0 plus NC3 plus NC6 so on is equal to 1 by 3 times 2 power n plus 2 cos n pi by 3. So, let us see how to do this problem. So, to do this problem, as usual, take 1 plus x whole to the power of n expansion, 1 plus x whole to the power of n expansion. So, what is the expansion? NC0 plus NC1 into x plus NC2 into x square plus so on NCn into x to the power of n. So, that is a clear. Here what the thing you have to do know. So, one more times NC3 x cube, some terms also I will write down. Why? Because they are needed, x to the power of 4 plus so on NCn x to the power of n. Clear. Now, what you have to do is put x is equal to 1 omega square. First put x is equal to 1 and x is equal to omega and x is equal to omega square. You know that in our complex numbers we explained what are 1 omega square. They are the cubed roots of unity. Okay, now right. First substitute 1. So, if you substitute 1, so this is equal to 2 to the power of n. So, this is a NC0, NC1 into 1, NC2, I won't write down, 1 square plus NC3 plus NC4, so on NCn. Okay, na? Next to write down omega, that is a 1 plus omega whole to the power of n is equal to NC0, NC1 into omega, NC2 into omega square, NC3 into omega cube, NC4 into omega 4 plus 4, so on NCn into omega power n. Next to write down omega square wherever x is there, 1 plus omega square whole power n. So, NC0, NC1 into omega square, NC2 into here omega square that is a omega power 4. Next NC3 omega power 6, NC4 omega power 8, so on NCn omega power 2n. Now, what you have to do is, so call it as this is a first equation. So, otherwise you can, I am writing this side. First equation, this is a second equation, this is third equation. Add 1, 2, 3. First equation plus second equation plus third equation, 1 plus 2 plus 3. Let us see what happens. So, this is equal to 2 power n plus omega whole power n, 1 plus omega square whole power n. So, if you observe, when you are saying 1 omega square are the cubed roots of unity, so we have the two results, that is 1 plus omega square is equal to 0, omega cube is equal to 1. Those results we have. So, if you add this here, you will have a 1 here 1. See here, NC0 plus NC0 plus NC0, 3 NC0, 3 times NC0. See here, NC1 you can take NC1 common outside, 1 plus omega square value is equal to how much? 0. Therefore, NC1 into 0, 0 you will get. Next one is here 1 omega square. Omega power 4 means what? Omega power 4 means omega cube into omega. That is omega cube value is 1. So, this is equal to omega. So, this is a omega. Again 1 plus omega square plus omega value 0. Therefore, NC2 term also will vanish. Coming to third one, NC3. So, here 1 is there. NC3 1. Omega cube value is also 1. Omega power 6 value is also 1. Omega cube whole square, 1 square 1. So, here 1, 1, 1. So, therefore, NC3, 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 3 NC3 will come. Therefore, we can take 3 common NC3. From this, you can say, next again, NC4 will go, NC5 will go, against NC6 will remain. NC6 plus so on, understand? Up to whatever may be the term. So, see here, NC0, we got it or not? So, left hand side part we got, of course, 3 is there. NC0 plus NC3 plus NC6 plus so on, got it or not? Now the answer is, now if you find out this value, that is 2 power n plus 1 plus omega whole power n plus 1 plus omega square whole power n value, if you find out, and if you divide with the 3, already it is 1 by 3 is there. So, if you show that, so this value is 2 power n plus 2 times cos n pi by 3, the already 2 power n is there, yes, 2 power n is there. So, these two values 1 plus omega whole power n plus 1 plus omega square whole power n, this value if you are able to show that, this value if you are able to show that 2 times cos n pi by 3, the problem is over. Okay, now. So, let us continue the solution. Hi students, welcome back here. So, the whole problem lies in then finding the 1 plus omega whole power n value, that is 1 plus omega whole power n value. First I will find out what is 1 plus omega whole power n. What is 1 plus omega? Already we know that 1 plus omega square value is equal to 0. Therefore, 1 plus omega value is nothing but minus omega square whole power n. Actually, what is omega? So, we know that this is a cubed root of unity, that is x. Therefore, 1 is equal to x cube minus 1 is equal to 0. Therefore, we have x minus 1 into x square plus x plus 1 is equal to 0. So, we got x is equal to 1. We have the two roots, one is omega and omega square. Okay, now, so what is omega? Omega is equal to minus b plus or minus root of so, minus 1 plus or minus, that means 1 root omega, next 1 omega square you will get. Minus 1 plus or minus root of b square minus 4ac by 2a. That is minus 1 plus or minus 3i by 2. That is equal to minus 1 by 2 plus 3 by 2i. Okay, now. So, minus 1 by 2 plus root 3 by 2i, that is omega. Omega square value you will get minus, but we want so you can call it as a omega square also, no problem. If it is a omega and it is a omega square is equal to minus 1 by 2 minus root 3 by 2, vice versa. If it is a omega is plus, omega square is here, minus will come. If it is a omega square is plus, here omega will become minus, that's all, vice versa. But here minus omega square we want. Okay, so here let us, so here omega is equal to minus 1 plus or minus 3i by 2. That means, so if you take a omega is equal to minus 1 by 2 plus root 3 by 2i, minus 1 by 2 plus root 3 by 2i. Then omega square will be minus 1 by 2 minus root 3 by 2i. The reverse will be there. Understand? Otherwise, if you take omega square, this is omega. That means the square of this value is nothing but this. Okay, right. Now, we want minus omega square value. Minus omega square value means what? So, this is equal to 1 by 2 plus root 3 by 2i whole power n. So, this is equal to cos pi by 3 plus I sin pi by 3 whole to the power of n. So, this is equal to cos n pi by 3 plus I sin n pi by 3. Similarly, 1 plus omega square whole power 1. 1 plus omega square means how much? Minus omega whole power n. Minus omega whole power n means what? So, if you take a minus, you have to multiply with minus 1 by 2 minus root 3 by 2i whole power n. So, you will get here cos n pi by 3 minus I sin n pi by 3 cos 60. Understand? Now add these two. If we add these two, that is equal to 1 plus omega whole power n plus 1 by omega square whole power n. What you will get? This cos, so let us check once here, cos pi by 3 set. So the sine terms will get cancelled. 2 times cos n pi by 3, 2 times cos n pi by 3. Almost we arrived the conclusion. So total value already, how much? This is a 2 power n is there, no? Therefore, if you add 2 power n, therefore omega whole power n plus omega whole square whole power n is equal to 2 power n plus 2 times cos n pi by 3. This whole thing is equal to 3 is equal to, okay na? 3 is equal to. So if you take 3 to that side, so the conclusion, that is a nc0 plus nc3 plus so on. So you will get 1 by 3 times 2 power n plus 2 cos n pi by 3. See here, these students, this type of problems you are getting in our JEE mains exam. So this is a problem of both complex numbers and binomial theorem. So to solve this problem, you should have the complete knowledge of this cubed roots of unity, omega square, binomial theorem expansions, everything you know. Okay. So I hope that you enjoyed today's class. With tomorrow's class, I will come before you. Until then, all the best.